This video tutorial shows you how to find a suitable maxon controller for your application. The controller, being at the heart of a drive system, has to fulfill several requirements. The most important one is to match the required task. What has to be controlled in the application? Speed, position or torque? The second point to consider is the type of command and the general system architecture. Where do the commands come from and how do they look like? Is the master system a PLC, a PC host or a microcontroller? Or is there a simple voltage set value? Of course, the controller needs to be made for the motor type to be used, be it brushed or brushless DC, and it must match the sensor types in terms of supplying power and understanding the sensor signals. The controller should be adapted to the supply voltage range and be able to handle the required electrical currents. Modern controllers are quite versatile concerning motor and encoder types, communication and operation modes. This requires proper setup or configuration. Let me first give a very general overview on the maxon controller families. The ESCON family is the first choice when it comes to dynamic speed control with analog set value. Cost-effective electronic commutation of brushless motors and simple speed control can be achieved with the DEC modules. The members of the EPOS family are the standard positioning or motion controllers with can-open interface. The maxPOS is a high-end position controller for extremely dynamic applications. The control performance increases from bottom to top in this representation. DEC and ESCON are speed controllers. EPOS and maxPOS are position controllers. We need to have a look at the maxon controller families not only with the focus on what kind of control they're made for, but also with the focus on how they communicate. The simplest way of commanding is by digital and analog in and outputs. For example, setting a speed by an analog voltage or changing direction with a digital high-low voltage signal. More sophisticated systems use bus communication with the master unit. At Maxon we use the cost-effective can-open and the high-performing EtherCAT interfaces. It's quite clear that the general architecture of the system, the master and the communication of the application at hand will have a major influence on the controller selection. The second feature is the kind of control. There are three main types: torque control, speed control and position control. Torque control on motors is equivalent to current control. It's the lowest control level. Controller with a torque control mode may be used as inner loop in an external speed or position control loop. In speed control we have to distinguish between simple one-quadrant speed control, usually working with low resolution feedback, and dynamic four-quadrant speed control with higher resolution feedback. Position controllers can usually also be set up as speed controllers. Let us place the maxon controller families in this scheme. The DEC modules are simple one-quadrant open-loop or closed-loop speed controllers based on the low-resolution Hall sensor feedback. An analog 0 to 5 volt signal serves as the speed set value. ESCON servo controllers are 4-quadrant dynamic speed controllers for brushed or brushless motors. The ESCON controllers are commanded by digital and analog IOs. There's no bus interface, the USB connection serving for configuration purposes only. The ESCON controllers are very versatile concerning feedback and set value options, as well as the configuration of the inputs and outputs. EPOS positioning controllers are can-open slaves. Set values and all other commands are sent across the CAN bus. Lower performance alternatives are the serial RS-232 or USB interfaces. EPOS controllers are not only position controllers but can also be set up as torque or speed controllers. EPOS 4 is the newest generation with improved performance and power, and a modular design that allows further implementation of additional features and communication options. The maxPOS position controller is a high-end EtherCAT slave with an extremely high control performance. It is used in demanding application in terms of dynamics, precision and synchronization. In summary, the pure speed controllers DEC and ESCON are commanded by simple digital and analog IOs only. The position controllers, EPOS and maxPOS, need a master system with more sophisticated bus communication. Simple IOs will not do the job. A short look at possible motors and feedback sensors. The main task of the DEC modules is to provide block commutation for brushless motors with Hall sensors. The Hall sensors are also used to get a low-resolution speed feedback. There's no encoder feedback possible, and the DEC modules cannot be used with brushed motors. ESCON servo controllers come in different versions for brushed or brushless motors. Speed feedback can be provided by encoders or DC tachos or by Hall sensors only. Open loop operation is possible as well. There's even an ESCON module for sensorless EC motors. Feedback from encoders is mandatory for the positioning controllers, be it EPOS or maxPOS. Depending on the exact controller type, a variety of encoders can be used. EPOS and maxPOS can power brushed motors or brushless motors with Hall sensors. Some practical issues when selecting a controller. Power. The main difference between the different versions within one controller family is the supply voltage range and the current capabilities indicated in the designation. The maximum current rating is typically twice or 3 times higher than the continuous current rating and can be available up to a minute. Between the different controller types, there may also be differences in the number and functionality of the additional IOs. Select the version that fits best to your application. Maxon controllers are made for a wide variety of motors and sensors. Check in the Maxon selection guide if the electrical interfaces of the particular motor and controller match, or if special adapters, cables and connectors are needed. Some combinations may also need additional inductances or motor chokes. This is particularly the case when using modules. The intention of the controller modules is to be integrated in the electronics of the application. However, for testing there are evaluation boards available with all the necessary electrical connections, capacitors and motor chokes in place. For all the controllers, all the documentation and software is for free and can be found on the Maxon website. As a summary, what are typical application fields for the Maxon controllers? The DEC is a simple speed controller, typically used for applications such as roller blind drives, blowers and pumps, or cutting and grinding devices. The ESCON is a very versatile dynamic current and speed controller. It can be used when the requirements about control performance are higher, as in conveyor drives, all kinds of handheld tools and scanners. The EPOS is the standard solution for positioning and/or if a bus communication is required. Typical applications include all kinds of actuators, laboratory automation, door drives and similar. maxPOS is a high dynamic and fast controller requiring a high-speed EtherCAT master system. It's perfect for demanding multi-axis control as in robotics, pick-and-place and on-the-fly processing. That's it. An introduction to Maxon controller families and how to select them.